So we've decided to build a Sudoku solver, and now we've come to arguably the most important thing we're going to do is we need to work out how on earth do we want to represent the Sudoku in the memory. So I first thought, okay, what I could do is I can take a single dimensional array. So it will just be a block of memory like this. So 0, 1, 2, 3, 4 in one row. And while that could work, it's going to be a massive pain in the ass to kind of eyeball it. Then I thought, okay, let me try to go for a 9v9 approach. That was what I kind of thought, okay, this one's no good. Let's try this because this could kind of work. And it did have its merits and it was better than the 1D array. But I found, actually, let me stop, rewrite everything in a 3-dimensional array, a 9 by 9 by 10, and you're going to see why, but this is just pure magic towards the end of things. So if this was a Sudoku represented by a single dimensional array, you'll have 0, 1, 2, 3, 4, 5, 6, 7, 8, 81 as its cell representation. Let's say I wanted to compare cell number 2 to, let's go, 9, 10, 11, 18. If I wanted to check for cell 0 and cell 18, are you the same number? Is any it's going to be so hard to write logic that will say, okay, if cell 0 and cell 18 are the same number, no good, because it would be very hard to find logic that would work for everything that I could write in a function that I could not do better as a higher dimensional array. Now I know that's a bit complex and I probably explained it poorly, but let's say in this Sudoku now we have this as cell 0, 0, 1, 0, 2, 0, and I would say, okay, for I equals 0, I less than 9, I plus plus, and for j, j less than 0, something along those lines, I could find a way to systematically check every single cell, row by row, column by column, row by row, far easier than I could with a single dimensional array. But here's where the magic got even better. I worked out, hey, if I could create a 3-dimensional array, a 9 by 9 by 10, this is going to make my life 100 times better. So what I thought was, okay, let's have our 9 by 9 right here, 9, 9, and then we have a depth of 10. Okay, actually I don't like that. Let me try again. Your 9, your 9, and we are going back 10. Okay, so what I was thinking is, let's take this Sudoku, right here, where is it? This Sudoku 928, and we'll put, we'll have, let's see, you're a 9, you're a 2, and you're an 8. And we'll just change color right here quickly. We'll go 9, 2, and 8. So in cell 0, 2, 0, 2, 0, you equal a 9. In cell 1, 0, 0, you equal a 2. In cell 2, 2, 0, you equal 8. Okay. And let's just take an example of this cell here, cell 0, 0, 0 equals 0. Okay. Now that we can look at this dimensional array, we have 10. Each one of these cells has 10 with them. So I can have 0, 0, 0, 0, 0, 1, 0, 0, 2, 0, 0, 3. You get the gist. All it is 0, 0, 9. Right. So I've decided the 0 cell here, this is going to represent the Sudoku. But every other cell here, I want you to represent an option the Sudoku can have. So if I'm going to make this clearer, you're 0, you're 1, you're 2, you're 3, you're 4, you're 5, you're 6, all the way to 9. And what I do is, let's say, for example, we're going to look at rows, because rows is 100 times easier. 6, 8, 6, 8. So we got a 6 and 8 over here. 6 and an 8. Okay, along this row, hey, I know you can't be a 6. I know you can't be an 8. So what I want you to do is find each cell in this row. So this is going to be row 1. Sorry, row 1, and then cross out every single 6. So you can't be a 6. 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 Okay. You can't be an 8. 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 You can't be 8. Same principle. So across there, 2. So what you've done is eliminate every single possibility for every other cell in that row. And then we'll look at the column quickly, which is going to be pretty simple. Column is going to be 8, 5, 3, 7. Wow, that's a lot of numbers. So let's go to 8, 5, 3, 7. What I'm going to do now is look at your row, and then for every single array here, I'm going to cross out, you can't be a 2, you can't be a 2, you can't be a 2. Obviously the depth isn't that great here, but you're essentially just crossing out all the 2's here. Let me change color. You're saying, no, you can't be a 2 downwards, you can't be a 3 downwards, you can't be a 7 downwards, you can't be an 8 downwards. So that is kind of how it works. If we were to change the view to be 0, 1, 2, 3, 4, 5, 6, we're looking at the array now from kind of like this angle. Hard to explain, but call this the front face. Front. So the front is it's this one, but now we're looking at the green. We just turned it one way to the side, and what it's doing is saying, okay, this entire set can't be 3, this entire set can't be 6, this entire set can't be 7, and essentially in a block of 100, sorry, it's 81, you have 810 possibilities in this box. 810. And what we're going to do is systematically cross out options. So, okay, you cannot be 3, for example. So you can't be 3. 3 is gone. We've just eliminated 9 possibilities. So we have 801 left over. Okay, you can't be a 3 downwards. Whoa. We've just eliminated another set of 8 possibilities. Yeah, let's just say 9. Now you've only got 782. Okay, whoa, you can't be... This entire box can't be a 3 now. So now we have another 9 possibilities gone. Let's just say 783. And this way, with this kind of structure, it's so much easier, you'll find in the later functions, to kind of eliminate possibilities. And that's why I said 3D array is the way to go.